I'm Erica Zavaleta, and this is Ecosystems of California. Today we're visiting the montane forests of California, and in particular we're visiting the montane forests of the Sierra Nevada. And like so many of California's ecosystems, California's montane forests stand out in a number of ways. They have exceptional diversity with over 30 different species of conifers, and in the Klamath-Siskiyou region in the northwest part of the state, that's one of the highest conifer diversities in the world. They also have these really marked seasonal dynamics and spatial diversity that are formed by their dependence on fire and the patterns of strong seasonal summer droughts here. I'm standing above the Merced River in the foothills of the Sierra Nevada, and we're just at the very bottom edge of what we can properly call montane forest. Montane forest begins with a mixed hardwood conifer forest, and behind me you can see both gray pines and some oaks as we transition out of the chaparral ecosystem that is characterizing some of the foothills around us. And to have a forest at all, you need certain conditions. We're a little bit low to be in anything that we would call a forest yet, but typically a forest is a place that requires about 80 centimeters of rainfall a year and has an average annual temperature of somewhere around 7 to 12 degrees Celsius, which is between 45 and 55 degrees Fahrenheit. That's the band in which these forests can thrive. And that band shifts uphill as you move south through the state. So at the northern end of the state, that band is shifted lower than we are now. Right now we're near Coulterville, California, about halfway up the state. And then as you go south into the southern Sierra and down beyond that, the forested band in the mountains shifts upslope. So we're a little bit higher up in elevation now in more of a true forest, and we're still in the mixed conifer hardwood zone here. So I'm sitting near some black oaks. And black oaks are just one of the hardwoods that you find in this zone. Some other common hardwood species or broadleaf species include things like interior live oak, canyon live oak, and golden chinkapin. And then the conifer part of this system can also include some different things. We saw gray pine at the beginning lower down, and as we're coming up higher, we're picking up ponderosa pine, a little bit of sugar pine, maybe some Douglas fir here and there. And as we go further south, we might also see some other things like coulter pine. So there's a mixture of species in the canopy. And in the understory, you can also see a variety of different things. Some of what we got are things like oak seedlings, but then we also have shrubs like manzanitas and herbs in the understory layer. And because these forests are affected by fire pretty frequently, we'll tend to see, at least some of the time, understory plants that fix nitrogen. So they form a symbiosis with nitrogen-fixing microbes in the genus Frankia, and in association with the Frankia are able to take atmospheric nitrogen, which is N2 with a triple bond. They're able to break that bond and make that nitrogen plant available. And so some of the species that can do that are shrubs in the genus Ceanothus, and then a whole variety of legumes like clover species. Historically, Sierra and montane forests burned frequently, with fires occurring every 5 to 40 years. And these fires were ignited largely by lightning and then later by indigenous Californians. Fires occurring every 5 to 40 years did a number of things for the forest. They cleared out understory brush and seedlings, thinning the forest and providing more light to the understory. They provided a pulse of nutrients to the soil, reduced competition for soil moisture, and then also created bare mineral soil beds for seeds to establish in. So in the absence of those fires, a number of things have happened. One is that pines have become less dominant in many forests in the Sierras. Pines once made up 40 to 65% of a typical forest stand, even at some higher elevations than we are now. But in the absence of fire, the shaded understory favors shade-tolerant species like incense cedar and fir. So in the absence of fire, those shade-tolerant species can grow up at really high stem densities, making it difficult for anything in the understory, including shrubs and herbs, to persist. One of the results of those changes in the forest is that they're much more susceptible to big stand-replacing fires. And behind me, you can see the results of a fire like that, where the canopy has burned as well as the shrubs and the seedlings in the understory layer. The fire behind me also burned a really large area. And so this huge part of the landscape now is all reset to a new forest. In the past, when fires were small and frequent, the landscape was made up of a mosaic of diverse patches of different forest ages, and what that did is support a greater diversity of animal species and provided habitat of different types, foraging habitat, breeding habitat, and so on, for particular wildlife species. Montane forests in California, and in the Sierras in particular, support about 355 different vertebrate species. And part of what supported that high diversity traditionally is that landscape mosaic of different ages and stages of forest following fires that occurred at different times in the past. So we're in a mixed conifer forest here. We've lost the hardwood element, and species in this forest include Douglas fir, like this cut tree on the ground, pines, incense cedar, and at least a couple of different pine species. I'm seeing ponderosa pine and the beginning of Jeffrey pine. A fire burned through here, just a low fire, and so there are some burned tree bases around us, probably in 2014 as part of larger fires that burned through this area near Yosemite. Now, about half of all Sierran conifer forests have been logged at least once in the last 150 years. And a lot of the logging early on was in the form of clear cuts. So the result of those clear cut areas is an even-aged forest without a lot of complex stand structure, without a lot of snags, dead tops, and mixed age canopy structure. But nowadays, more of the logging in the Sierras looks like this. It's selective cutting, and this looks like a salvage logging project in particular. So one where, because there was a fire that burned lightly through here, trees are being removed selectively that have some fire damage to use the wood before it rots. They may also be removing some wood from here because in the absence of fire in a dense forest like this, the only way other than a prescribed burn to try to reduce density, get some of the stems out, reduce the risk of catastrophic fire in the future, can be to thin out some of the trees. This is a controversial practice because taking out trees is very different from burning them. There's no pulse of nutrients to the soil. There isn't the same structure of downed and dead wood that you would get if you had a light fire burn through here. But in a lot of cases, it's really difficult to have a prescribed burn happen, to have an intentional fire, because of the risk that that potentially poses to human health and safety and to structures. So in the absence of the ability to do prescribed burns in some areas, salvage logging like this is another way to thin out the forest. We've reached the upper Montane forest belt in Yosemite National Park. So we're a little over 2,000 meters in elevation right now, about 6,500 feet. We've moved out of a pine-dominated forest and into one that's characterized mainly by white fir, which is this species behind me. White fir still is co-occurring with a lot of different things. So around me there are Douglas fir, there's Jeffrey pine, there's still a little bit of sugar pine, although we're reaching the upper elevational limit of sugar pine. We've also sort of reached the upper limit of ponderosa pine. And one of the interesting things that's going on here is that we're on a south-facing slope. So even though we are in this white fir forest zone, it's a pretty arid setting, and there's space between the trees. There's a lot of shrubs in the understory. This is bush chinkapin, Chrysolepsis sempervirens. It's a species that actually burl resprouts. So after a fire, it'll burn to the surface, and this species can resprout from the burl. So it's adapted to these more fire-prone sites like this hotter, drier, south-facing site. It also produces these nuts, incidentally, that are an important food for a variety of birds and mammals. And then also, because we're on this dry, relatively hot site, because we're in this Mediterranean climate system and we're high enough that there's snowpack and snow cover here for a lot of the year, the growing season's pretty challenged. It's a short season of overlap between moisture availability and warm temperatures. Most of the time it's either cold or it's dry. One of the results of that is that decomposition is really slow and nutrient levels in the soil are pretty poor. So you'll see on slopes like this more things like lupins, these nitrogen-fixing understory herbs. They have a competitive advantage here because they're able to, in symbiosis with Frankia microorganisms that form root nodules on their roots, they're able to fix atmospheric nitrogen. So they can pull their own nitrogen out of the atmosphere rather than rely on what's here. And part of what they fix goes into the soil and increases nitrogen availability for them and for all the other plants growing here. So you have nitrogen-fixing plants in these relatively nutrient-poor, well-drained soils, but that's an expensive strategy to fix nitrogen. You've got to put a lot of energy into it, and so they don't do as well in settings where there is more nitrogen available anyway, and plant species that aren't putting so much energy into maintaining this ability to fix nitrogen can outcompete them. So it's at this elevation that you can really see the important influence of the parent material, the substrate, on the dynamics of these ecosystems. We're in the South Central Sierra, and the parent material is this granite. So the granite forms really, really fast-draining, poorly developed soils. And when granite underlies a montane forest, you get certain kinds of tree species. There are a lot of pines here in Yosemite. If you go further north just a little bit, you get into metamorphic and volcanic substrates, and then the forests change. And they change because the soils have different properties around nutrient and water holding capacity, among other things. So you get things like red fir that we're not finding so much here. At this elevation, just above Olmsted Point, we've left the montane forest zone. We've entered the subalpine, and so most of what you see is not trees, although there are still trees here. Once we're up in the subalpine, the dominant forces become abiotic, and so we'll talk about those on another trip.